Welcome back everyone to part 2 of this manual neural network lecture series where we're going to focus on the operation class we'll be building. So the operation class we create, it's going to have two main attributes, that is input nodes and output nodes. So the input nodes, as you may have guessed, is just a list of input nodes that are going into this operation, and output nodes is a list of nodes that are consuming this particular operation's output. Then inside of this operation class, we'll also have a global default graph variable, which we'll explain in a second, and then we'll have a compute method. And this compute method is going to be essentially overwritten by an extended class that inherits this operation class. So let's discuss a little bit about what a graph looks like, and then what's going to happen with this compute method. So a graph is essentially going to be a global variable, and the reason we're using this term graph is because TensorFlow runs off graphs, and we'll kind of reiterate this when we learn about the TensorFlow basics in the next section. But you can imagine a graph as kind of this list of nodes, and in this case we have this sort of really simple graph where we have two constants, or two nodes, n1 and n2, and each of those is a constant, 1 and 2 respectively, and then those are feeding into some sort of operation node, n3. So in our case, we have kind of this skeleton operation class, and then this operation class is going to be inherited by other classes. So for example, we can have an add class that inherits this operation class, and in that case it takes in those two inputs, 1 and 2, and then it outputs 3 because 1 plus 2 is 3. Or maybe we have a multiply operation. So that multiply operation is just going to say 1 times 2 and output 2, etc. So that's the very basics of what a graph would look like. Obviously, when we're working with TensorFlow, we won't have to deal with this so manually, but there will be a really complex graph in the background that TensorFlow is kind of constructing everything with. So now that we understand the very basics of what we're going to create, let's jump to the Jupyter Notebook, create this operation class, and then also create a couple of operations, such as addition, multiplication, and matrix multiplication. Let's hop over to the notebook. Okay, here I am at the notebook. Previously, we kind of just discussed this really basic OOP, and then the super function. Let's go ahead and put in our operation class. So our first class is going to be operation. This is just a markdown cell. We'll start with class, then we'll say operation. We'll start with our init method, which going to happen when we actually create an operation. That takes in self by default, and then we'll have input nodes as a parameter, and we'll initialize it with no input nodes by default. But then we can also pass in, self, and say input nodes is equal to input nodes. And then we're also going to have output nodes. So we'll say output nodes is equal to, and in this case, we'll just have an empty list. So that list of output nodes is later going to be overwritten by the actual class. That is the operation that inherits from it. Okay, so we have our input nodes and our output nodes. The next thing we're going to do is we're going to say for every node in the input, we're going to append this particular operation, this self operation, to the list of the consumers of the input nodes, that is the output nodes. So that's a little for loop. So inside of this init method, I'm going to say for every node in my input nodes, what I'm going to do is say grab that node, grab the output nodes for that particular node, and then append self, which is essentially just a reference to this current operation. So again, for every node in the input nodes that are going into the operation, I'm going to append this operation to the output nodes for that node. Essentially saying, hey, once you're done with this operation, you're going to output it to whatever output nodes are related to this particular node. Then finally, I'm going to have this compute method, self, and I'm just going to put a pass in there because essentially this is just a placeholder method, and it's going to be overwritten by the actual specific operation that inherits from this operation class. So I know it's a little confusing right now. These three lines are kind of a little mysterious, but once you see this whole thing at scale with the other operations, placeholders, variables, and graphs, I think it's going to make a lot more sense. Okay, so let's go ahead and create some example operations such as addition. So to do that, we'll have add operation, then we'll say def, init. It's going to take in self, and then the two things that we're going to add together are x and y. So because we're adding these two things together, those are essentially inputs. So those are going to be our input nodes for our operation. So let's go ahead and say super dot init and initialize our operation by passing in a list of those input nodes, kind of following along with that graph that we just saw previously. Then we're going to say def compute, and this is going to overwrite the compute function here, and this is essentially going to perform the actual computation operation of addition. So we're going to say self, and it's going to be whatever x variable we have, whatever y variable you have, and technically you could use x and y instead of x underscore var, but this is just so it's a little less confusing, at least for me. And then we'll say self inputs is equal to whatever x variable we have, whatever y variable we have, and then we're just going to return x var plus y variable. Okay, and again, since this is kind of self-contained, it's up to you whatever these variables are called, but I'm just kind of make it separate that these are computations. All right, so that's the very basics of a operation. So again, all we're doing here is we're setting up the input nodes to this operation, where it's going to be outputted to, so the output nodes, then we initialize that per operation, in this case, really simple one, x and y. So we're inputting x and y, and then these inputs are going to, when they're computed, return their sum. So let's go ahead and make two more here. So instead of add, we're going to make one called multiply. And typically for classes, these would actually be uppercase, but to follow along with TensorFlow's naming convention, I'm having them be lowercase right now, because when we use them in TensorFlow, these function operations like add, multiply, matrix multiplication, they're actually lowercase. So this is kind of so it just follows along more with TensorFlow that we'll see in the future. All right, so multiply, going to be the same thing, except down here, we're going to say times. And boom, that was pretty easy. And finally, let's do a matrix multiplication. So that will be mul, matrix multiplication. And this one's going to be the x variable, and then we're going to say dot y variable. We're going to basically assume that it's a NumPy matrix or NumPy array, and that can then have a dot method off of it. So the dot product here for matrix multiplication. Okay, so those are our operations. So again, we have this base operation class, and then off of that, we can kind of overwrite this compute method for adding, multiplying, and matrix multiplication. There's a lot more we could do here, things like reduce mean, that kind of thing that we'll see later on in TensorFlow, but for our very basic example, this is essentially all we need. Okay, coming up next, we're going to discuss placeholders and variables and then finish out our actual graph class. I'll see you at the next lecture.